Hello everyone, and welcome to our 9.6 notes on angles of elevation and depression. We are still going to be working with Trig. Trig is not going away. So we're going to write SOHCAHTOA at the top of all of our assessments, all of our assignments, all of our notes. The only difference with today's lesson is instead of the triangle being drawn and you finding a missing side length or angle, you're actually going to have to create and draw a picture of the right triangle from the given word problem. So before we get too far into that, we need to talk about angles of elevation and angles of depression. So what is an angle of elevation? An angle of elevation is going to be formed by a horizontal line and a line of sight to a point above the line. So if you have person B, here's their horizontal line. Person B would have a horizontal line of sight. If you had somebody standing right here, their eyes would be looking straight ahead if they looked like this. But if they looked up at person A, at point A up here, that is going to create this angle between the blue and the pink. That is an angle of elevation. Their eyes are elevated above that horizontal line. So that is an angle of elevation. So then what is an angle of depression? This angle of depression is going to be formed by, again, a horizontal line and a line of sight to a point below the line. So if you have person A, let me erase this. If you have person A, and person A's, their normal line of sight, if they're standing up here, would be straight ahead. So you see their horizontal line. But if they have to look down or peek down at person B, that is going to create this angle right here, which is going to be my angle of depression. So it's formed in between the horizontal line and what looks like that transversal to that other parallel line. But that's this one right here. This is the angle of depression. Okay, so it falls, important thing to note, it's going to fall in between that point below the line. So they're looking down from their line of sight. So the first three problems say determine whether the numbered angles are angles of depression, angles of elevation, or neither. It could be neither. So the measure of angle 1, well, where does angle 1 fall? Let's just kind of look at where it's at. So angle 1 is falling right here. Angle 1, we do not have a horizontal line of sight that it's touching. And so that is going to be neither. That is our most common thing that people mistake that for. That is going to be a neither. Angle 1 is neither. Okay, but let's look at angle 2. Angle 2 is falling between that person's horizontal line of sight and they're looking down at that boat. And so that is going to be an angle of depression because they are looking down at the boat. Okay, so that's our depression angle. All right, if you have somebody on the boat, their normal horizontal line of sight would be right across the water. But if they're looking up at that person, you can see that their eyes become elevated. So angle 3 is going to be an elevation angle. Okay? So you're looking at if angles are opening above a horizontal line or below a horizontal line to find those. All right, and now I have just quite a few, I should say, word problems. And you notice on every single one of these, I do not have a single picture. So we're going to have to create these pictures. And just something that I have recognized that helps students over the years is that they draw the picture the same way every single time. And so we're always going to draw our triangles the same way. You do not have to draw them the same way as me, but as long as you are consistent, I feel like that will help you. So it says solve each problem, and then this is interesting. They tell you what to round. They want the side lengths rounded to the nearest tenth. But if we're ever finding an angle, they want the angle rounded to the nearest degree. Don't forget that the nearest degree just means the nearest whole number, the nearest whole number. Okay? All right, so Harper is flying a kite. She lets out 105 feet of string and anchors it to the ground. So the first thing we need to do is start with a picture so that we have some reference here. So I'm going to draw a picture of a right triangle. And she is flying a kite. So where is that kite going to be? Well, we hope if she's flying it well that it's going to be in the air. So here's my kite. And she lets out 105 feet of string and anchors it to the ground. So we know that like when the wind is blowing, here's my string. I can put an amount on there now. That's 105 feet of string. So all of these are going to be right triangles. And this is our hypotenuse that's given, 105 feet of string. And she anchors it to the ground. So she anchors it right here on the ground. She determines that the angle of elevation of the kite is 48 degrees. So you need to find your horizontal line. Here's my horizontal line, which is the ground. Maybe it's the sand at the beach. And in the angle of elevation opening to the string, that angle is going to be 48 degrees. So we get to fill that in right here, 48 degrees. We want to know how far the height of the kite is to the ground. So from the kite to the ground would be this piece right here. So I'm going to put an X there because that's what we're looking for. Because that's a side length, I know that I'm going to round that to the nearest tenth if I need to. All right, so now we've created a right triangle, and we just have to figure out what trig function this is. So from the 48 degrees, that's my vantage point. This is going to be my opposite. And then this piece right here is going to be my hypotenuse. So what trig function goes with opposite and hypotenuse? Look at your SOHCAHTOA. That is going to be sine. Since I'm solving for a side length, I know that I'm going to be using normal sine here, not inverse sine, so normal trig. So the sine of 48 degrees is going to be equal to opposite over hypotenuse, so that's x over 105. Remember to make this a fraction, we put it over 1, and then we're just going to cross multiply. This becomes x is already by itself, so x is going to be equal to coefficient of 105 times the sine of 48. And let's see how high up this kite is flying off the ground. 105 times the sine of 48. Again, that's normal sine. To the nearest tenth, it says, is going to be about 78.0 feet. About 78.0. So that's how high up that is, and that does make sense as an answer because that is less than the hypotenuse. So we still do that where we go back and just double check ourselves. Check yourself before you wreck yourself. So Harper's flying the kite. Harper's flying at 78 feet in the air. That's pretty impressive. All right, so Morgan's not flying a kite. What is Morgan doing? Morgan is taking a balloon ride. So let's go ahead and start with our right triangle. We're always going to create this right triangle. Okay, taking a balloon ride, and after 25 minutes, he measures the angle of depression from the balloon to its launch place as 24 degrees. The first thing I'm going to do is draw a little balloon. Y'all don't. I know you're sitting there judging if you're watching this. I'm sorry, I'm not good at this. Okay, so he's in the balloon, and here's the little basket in the balloon. And he measures his angle of depression to the launch place. So here's my launch place, maybe, as 24 degrees. Now, this is important to note. From his eyes, if he were looking out, that would be his horizontal line of sight. So it's parallel to the ground. So from his eyes, he's looking down at an angle of 24 degrees. Well, unfortunately, that's not in my triangle currently, the way I have it drawn. But we know that because these lines are parallel, because this horizontal line is parallel to this horizontal line, we have something called alternate interior angles. So if the angle of depression is 24 degrees, we can also copy this angle of depression from here. Its alternate interior angle is going to fall right here. And so we know that those are going to be congruent to each other. So I can put a 24-degree angle right here as well. And I'm going to make his angle of elevation from the balloon. I'm going to make that his depression angle. I'm going to make that the elevation angle of the triangle because those are going to be alternate interior angles. So do not try to put that 24 right here. We have to put it from the horizontal line, from his line of sight. Okay. He is 210 feet above the ground in the balloon. So I'm going to throw that here, 210 feet above the ground. That's his height off the ground. And we want to know the horizontal distance from the balloon to its launch place. So that is not this piece right here. It's not the hypotenuse. The horizontal distance would be like how far would somebody need to drive from point A to point B so that they're under the balloon. That's the horizontal distance. So we're looking for this piece, and I'll call it X. Okay? So then we just need to figure out what's given. What is 210 in regards to my 24 degrees? That's going to be opposite. And then the X is going to be the adjacent. What trig function goes with opposite and adjacent? That is going to be the tangent. Okay, so that's our horizontal distance was key there. We're finding the horizontal distance from the ground. Okay, kind of think about it like if you had to have somebody come, hopefully you don't have to have this when you're in an air balloon, but if you had to have a rescue car drive from the starting point to the stopping point, how far would they have to drive? And that's what we're looking for. And so we're going to have the tangent of 24 degrees is equal to its opposite, which is 210 feet in the air, over its adjacent, which is what we're looking for. So we're going to cross multiply. We're going to put this over 1 and cross multiply. Unfortunately, this is where x is going to be attached to the tangent of 24, so we know ultimately we're going to end up having to divide 1 times 20 is, or 1 times 210 is 210, and then we divide by the tangent of 24 to move it to the other side to get x by itself. So let's see how far away this person is going to have to drive to be under that balloon. 210 divided by the tangent of 24. We want to round that to the nearest tenth, it says, because it's a distance. They're going to have to drive about 471.7 feet to get to that, to be under that balloon. Okay? All right, so we're going to draw those triangles the same way every time and just kind of make the situation fit. All right, so who are we talking about next? Paxton. Paxton is on an airplane. So let's draw our picture first. Here's my right triangle. So Paxton is on this airplane. Here y'all go. Brace yourselves for this one. It's going to be looking like a bird. Hold on. Ooh, ooh. There we go. Hey, that's not half bad. You have to admit it. If you're watching this, that's not half bad. He's on the airplane, and it takes off 200 yards in front of a 60-yard building. So where is my, so this one's taking off, y'all. I did all that work, and now I'm having to erase it. So I should have kept reading. The airplane is taking off 200 yards in front of a 60-yard building. Okay, so hold on, let me do this. So our plane, oh, y'all, I have to go backwards. Here we go. That is significantly worse. But here's our plane. It's on the ground. It hasn't taken off yet. And it's taking off 200 yards in front of this building. So where's my building? I might draw my building right here. Here's my building. Okay? So this is like the runway. And it is 200 yards in front of this building. So obviously, I don't know about you, but I know that when I take off in an airplane, I do not want to hit a building. I want to avoid the building. So it's 200 yards in front of a 60-foot building. Okay? And so what we're going to do here is, it's 60 yards, so perfect. We don't have to have any conversions. All right, so we have 200 yards in front of a 60-yard building. At what angle of elevation does this pilot need to take off to avoid crashing into this building? So he needs to go higher than a certain angle. And so since these are both in yards, thankfully I do not have to do any conversions. So yards and yards, both yards. And what we're going to do is we're going to figure out what trig function that is. Now I want you to pause here. We know, since I'm looking for an angle, if I'm ever looking for an angle, I'm going to be using inverse trig. So inverse trig is going to give me this angle, and I'm going to call that angle theta. Okay? So from theta, what is the 60? The 60 is going to be the opposite. What is the 200? The 200 is going to be the adjacent. So we know that that's going to end up being the inverse tangent. So this angle, theta, is going to be equal to the inverse tangent of 60 yards over 200 yards. So when we type that in, inverse tangent, 60 over 200, that is going to give me about 16.7 degrees. So we want to round angles to the nearest whole number. So what we would say is that I need to take off at a degree of 17 degrees or more. If not, I'm going to hit this building. Okay? At what angle of elevation must the plane take off? 17 degrees or anything bigger than that, the plane's going to avoid hitting the building, and it will clear it. Anything below 17, the plane might hit the building. All right, so what about Zach? Zach, if you're watching this, I gave you this one because this is one of the hardest ones on here, okay? So Zach is standing 400 feet from the base of an apartment building. So here is Zach, and he is 400 feet from the base of the apartment building, okay? The angle of elevation from his eyes, boom, boom, there's Zach's eyes, which is 6 feet above the ground, so Zach is tall. 6 feet above the ground, is going to be 32 degrees to the top of the apartment building. So when he looks up to the top of this apartment building, it makes a 32-degree angle with his line of sight. Find the height of the building. Now, this is what's tricky. We assume that Zach is standing on the ground, yes? But when he's looking at the building, he's leveled up. He's not staring at the building. He's not laying his head on the ground. He's looking from 6 feet above the ground. We know that the building is also, hopefully, standing on the ground. So here's my building, just like before, just like in the plane example, there's my building. But what we're going to end up having to do at the very end, whatever we find, is only going to give me the height of this portion of the building. So what I'm going to have to end up doing ultimately is adding Zach's height of 6 feet at the very end to whatever I get for the yellow to see the total distance of the building, okay? Because my ground is under Zach's feet and under the building's feet. Okay, so this is still a right triangle. This is still a right triangle. And so what I'm going to do is I'm going to use some trig, but what I want to do is I want to put the missing piece right here as x. And then ultimately what we're going to do once we know what x is add it to this little pink piece, which is going to be his 6 feet. We're going to have to add 6 at the very end. Okay? So what is the x? From Zach's perspective, the 32 degrees, this is going to be my opposite. And then he's 400 feet away from it. That's going to be his adjacent. So what trig function goes with opposite and adjacent? That's going to be tangent. So the tangent of 32 degrees equals opposite, which is x, over adjacent, which is 400. Again, I put this over 1, and I'm going to cross multiply. So x is going to be equal to 400 times the tangent of 32, when I cross multiply that. Okay? So 400 times the tangent of 32 is going to give me 249.9. So that is going to be, we want to add, after that, we have about 249.9, and we want to add the 6 feet that Zach stands to that. So we're going to add 6. At the very end, we're going to say plus 6. Let me color code that. That's going to be plus the 6 feet that he stood tall, so plus 6. And we get about, when you round it, about 256 feet. Ultimately is what the building is going to be. So overall, 256 feet tall. Because this little portion was 249.9, and then the 249.9 plus the 6, ultimately the whole thing became a height of 256 about. 256 is how tall that building stood, because we had to add Zach's height. Okay, now we have a ski run. Who's on the ski run? Let's see. Robert is on the ski run. So let's go ahead and draw a right triangle, per usual. Here's my right triangle. He's on a ski run that is 1,000 yards long. So where are we actually skiing on this hill? The snowy part. So that's going to be 1,000. 1,000. 1,000, okay. Yards long with a vertical drop of 208, meaning how tall is Robert actually standing when he's at the top of this mountain? That vertical drop is going to be 208 yards. And let's make sure these are both in yards, yards, and yards, so there's no conversions needed. We want to find the angle of depression from Robert's eyes to the ski run at the bottom. So where would Robert be looking if he was skiing? That would be right here. So the angle of depression is going to occur here. Now, sadly, that is not in our triangle, so what we need to do is we need to copy it to its alternate interior angle. So where is going to be alternate interior to these? His horizontal line of sight is parallel to the ground, and so where is that going to fall? That is also going to fall right here. So we get to copy that to the angle of elevation in the triangle. Okay? That helps me out because now 208 yards is opposite. 1,000 yards is hypotenuse. So I'm going to use, to help Robert, I'm going to use the sine function. And I know that since I'm finding an angle, it's going to be inverse sine. So that is going to be the inverse sine of my angle. I'm going to call that theta. Inverse sine of theta. Theta is equal to the inverse sine of its theta's opposite, which is 208, over theta's hypotenuse, which is 1,000. So what is the inverse sine? Let's see how the angle of depression for Robert is going to be 208 divided by 1,000. And that is going to be, he's going to be looking at a 12-degree angle. So from Robert's line of sight, that's going to be 12 degrees. So this is 12 degrees, and then this is also going to be 12 degrees. Ultimately, the final answer. Okay. So that would be his angle of depression. All right. What is Emma Parker doing? She's doing something with the ladder. She's leaning a ladder against the wall. So we have another building. So let's draw the right triangle. And we are leaning this ladder against the building, which we hope is standing on the ground. She leans this ladder against a building and makes an angle of 78 degrees with the ground. So I'm going to do here's the ladder. I always like to do these little marks on it because it kind of helps me think through if it gives me the length of the ladder. That's where I put it. Okay, so she leans that against the wall. The 78 degrees is what the angle makes with the ground. So that tells you the ladder and the ground makes a 78-degree angle. The foot of the ladder is 5 feet from the building. So the foot of the ladder, here's the foot of the ladder. It's 5 feet from the building, so that's going to be this piece right here. So there's the ground. And we want to know how long is the actual ladder. So the ladder itself is going to be this length. Okay? So we want to find out how long is the ladder in feet. And so here is my hypotenuse from the 78-degree angle. Here is my adjacent from the 70-degree angle, but those both frame the angle. Remember, we kind of talked about it essentially makes like the mouth of a crocodile where it frames the 78 whenever you have your adjacent and your hypotenuse. That's the hardest to see. And so that is going to be cosine. And I know that I'm going to be using normal trig because I'm finding a side length. So it's going to be the cosine of 78 degrees. The cosine of 78 degrees is going to be equal to 5 over x. And we want to put this over 1 so that we can cross multiply. So when I cross multiply that out, x is not by itself. It is attached to the cosine of 78. 1 times 5 is going to be 5. And so now to get x by itself, I'm going to divide by the cosine of 78 on both sides. Divided by cosine of 78, divided by cosine of 78. So the cosine of 78 is going to cancel out, and you do 5 divided by cosine 78. Let's see how long this ladder is. This is a pretty standard ladder. It's going to be about 24.0 feet long. 24.0 feet long. Would that make sense as an answer if I went back and put that in for the hypotenuse? Yes, because the hypotenuse should be the longest side. All right, last two. It says, if the tangent of an angle is 5 over 12, Vincent wants to know what is the cosine of the same angle and what is the sine of the same angle. So the first thing we're going to do is we're going to draw a right triangle. And it doesn't tell us what angle we're working with, but if it says that the tangent is 5 over 12, the tangent of that angle, theta, is going to be 5/12. We're going to pick one of the two acute angles to work with. So I'm going to pick my angle of elevation like I've been doing, just so I can stay with the consistency portion of that. So tangent is opposite over adjacent. So even though it looks like we don't have any sides, we actually do. Here's my ratio. Opposite to adjacent is 5/12. So opposite this angle is going to be 5. Adjacent this angle is going to be 12. So there's my 5 piece that's opposite. Here's my 12 that is going to be our adjacent. Okay, so it wants to know what is the cosine of the same angle. So what is the cosine of theta? And it wants to know what is the sine of theta. Okay. In order to know the cosine of theta, I'm going to have to know the adjacent over the hypotenuse. I know the adjacent, I don't know the hypotenuse. For the sine, I need opposite and hypotenuse. So essentially what I'm going to have to do is find the hypotenuse here. So how do I find the hypotenuse? I can't use trig because I don't know the angle, but I can use a theorem that goes with right triangles in finding the hypotenuse. It's called Pythagorean theorem. So I know that 5 squared plus 12 squared is going to be equal to c squared. And so I just type that into my calculator. I end up getting 25 plus 144 is 169. So c squared is 169. So what is c? It's going to be the square root of both sides. So c is going to be 13 exactly. So I was able to find my hypotenuse using Pythagorean theorem. Why does that help me? Because now I can find my cosine ratio. It's going to be adjacent over hypotenuse, so it's going to be 12/13. And then the sine ratio is going to be opposite over hypotenuse, so it's going to be 5/13. So we were able to find our missing pieces after using Pythagorean theorem. So Vincent wanted to know what the answers were, and here they are. All right, Ollie is wondering about a different triangle. In his mind, he's dreaming up a triangle where the sine of A is 3/5. So let's go ahead and fill in an A. Sine of A is 3/5. So he's working with this angle right here, theta. Sine A equals 3/5. We know that's opposite over hypotenuse. So where can I fill in a 3? Opposite the theta. It's my opposite. Where can I fill in a 5? On the hypotenuse. And so he wants to know what is the tangent of A. So if I'm going to know the tangent of A, I'm going to have the opposite piece and the adjacent piece. Obviously, I'm missing the adjacent piece right now, so I'm going to throw an X right there. And again, we're going to use Pythagorean theorem. So what's my hypotenuse? That's important to note. My hypotenuse is 5, so that has to be the C value. So when I plug this into the Pythagorean theorem, that is going to be 3 squared plus x squared equals 5 squared. Okay, so we're going to subtract 3 squared from both sides. Now I want to pause because a few of you had some trouble with this on the last test. This is not just 5 minus 3 squared. It's not 2 squared. This is saying 5 squared. You have to do order of operations. So order of operations says that's 5 times 5, which is 25, minus 3 squared, which is 9, and then 25 minus 9 gives me 16. Okay? So x squared is going to be equal to 16. If you had done 5 minus 3, that would be 2, and then 2 squared is 4, so that wouldn't have been enough. So make sure you're doing your order of operations. You can also type that in all at one time, this whole thing into your calculator. 5 squared to the second power minus 3 to the second power. Your calculator will do that for you. So we're going to take the square root of both sides. And what is my x value? My x value is going to be 4. So this is a 3, 4, 5 triangle. Some of you might have known that from the beginning because that is our most famous right triangle, our Pythagorean triple. Okay, so what is tangent going to be? From A, the opposite would be 3, the adjacent would be 4. So your assignment is going to be on the next page. It's got identifying some angles of elevation and depression, or neither, and then it's got some word problems. Y'all know that this is just going to take a little bit of practice, so if in doubt, you're always going to draw it out. And so we will go over those tomorrow in class. But look at how pretty our notes are, y'all. This is fun. It feels like art class. Obviously, I'm not an art teacher, though. Thank you for your patience, and I hope you have a wonderful day.